Welcome back. We'll study the characteristics of synchronous motor. This is part 2. We'll start from step 10. The step 10 we'll do this circuit. This circuit. From the circuit we can see for the
current,
field part. So we need DC supply. This is the positive DC. So this is positive DC. This will connect to positive of I3. This is positive of I3. Okay. The negative of I3, it will connect with resistive load. Negative of I3 connect with resistive load. This is negative of I3. This is negative of I3.
So
negative of I3. This is negative side. Connect
like
with
that.
resistive load.
Yeah.
This is resistive load. Now the opposite of resistive load, it will connect with the field circuit.
Wait.
See, this is resistive. Opposite of resistive load, it will connect the field circuit. So this one, this is positive. It will connect with the 7, positive of field circuit. Positive of field circuit. This is field circuit. This one.
So one
Connect
end
it.
of the field circuit
Yeah.
is going here to
And
7
then, yes.
into one side of load.
Then other side of
8.
field circuit, it will back to neutral. Other side of field circuit, it will back to
Negative, which is
negative.
neutral.
So this is other side of supply. This is negative. As for the armature side, same thing. We already connected previously. This is speed. Output of speed torque is connected with data acquisition system. Similarly, speed is connected. We also connect the grounding. Same thing like previously. Now this time for the synchronous motor, we need to connect the voltmeter between 1 and 2. Then there are 2 lines for 3 phase, but this is 2 line, 1 and 2. So 1 is connected with E1 positive. So I can see this is the 1. This is the synchronous generator. This is 1. It will connect positive of E1. So 1 is connected with positive of E1. Now the negative of E1 is connected with 2. So negative of E1, it will connect with 2. So this is 2. Now we need to short this other side.
4 and 5,
Yes.
5 and 6.
Yes. Now this is complete. Now step 4. We need to measure like a voltage E1. We just connected. This is E1 voltage. Field current. This is I3. This is I3 field current. Then we need to measure speed and frequency. So from the software, if you see, open this one. I just select. We need to measure like from here. If you see voltage E1, like E line 1, field current, speed and frequency. Similarly here, voltage, speed, field current and frequency. Okay. So for this table, we can see that for 200 volt, 240 volt, the field current will be 450 milliampere, and it mentioned that we have to increase the field current up to 450 in 10 steps. So we can start from 45 milliampere, then 90 milliampere, then 135 up to 450. So it will be 10 steps. Okay. So you can see that. If we turn on the supply from this, this is field current. So we need to make it for this one we can vary the resistive load, also the exciter. So if we select this one first, if we select 4800, also vary the knob.
Which is the exciter.
Yes, exciter.
Yep. We're setting it to 45 milliampere, yeah?
Yes, 45 milliampere.
You can see here, increase the voltage.
That's 0.045 ampere, but here it's milliampere, so make it ampere. It's milliampere, 45 milliampere, that means 0.045 ampere.
Where is the okay, here. This is the right, so 45 milliampere voltage, we need 240.
Yeah, maximum will be 450, but we need to increase by 10 steps.
Yes.
So 45. So I can say that if we make it on 500 and turn on, we get the result. Oh, sorry. I think we can install, we can remove this and we can check from here. Now we need to increase the what is called
45 milliampere, which
now
is
it's
the field
to
current.
0.09 90 milliampere, so we can do
Off.
we can increase, now make 2400, now
So
2400,
100 ohms.
and we need to make it 90.
We need to double the currents or the field current.
Yes, so we can say that we make it 0.09,
Yes.
that means 0.09 milliampere. If we convert it to milliampere, it will be 90 milliampere. Okay, so same thing we can do now. If we turn on, similarly we have to increase the field current up to 450. So if I want to, I did this one. If you see the result, with step 12, I can show you the result. Step 12. This is the field current. We increase field current, so it will be 450. So it's almost 450, 447. So for this case, for every step, we see the frequency, we see the speed, and we see the voltage. This is step 12. For step 13, same thing, but we need to short the resistive load by connection lead. For example, same thing, just we will short
the
load, and the field exciter, it will be clockwise, that means maximum. Now it's maximum. Now we need to do same thing,
Okay.
like we need to increase the field
Field
current
current.
450 with 10 steps. So I already did. You can same thing.
Do one.
So if we see, you can remove this one. You can start. This time we need to short. This is 0.44, you can see. This is the voltage. Now the field. Now the field current will be double 90, because we need to increase by 45 milliampere, so it should be 90. Now you can see it's a 90 field current. Now you can see 90 field. So this way you have to increase up to 450 milliampere.
10 step.
10 step. So I can show you this is step. This is actually the result is for step 13 and 14. You have to do you have to give some the answer of the question something 13 40. So this is all about the answer for 13 step 13, and you can see that we increase the field current up to 450. In step 16, from the same the data, you have to plot a graph. It will be field current versus output voltage. You have to answer the questions. The questions is there in